Here is my setup for this experiment. There's a large magnet tacked to the floor with some putty, and it's pointing north towards the Earth's north approximately. And then over here I have an aluminum pan filled with water and a little boat made out of a rectangular food container, and that has some magnets in it. And you can see the north end of the magnet is pointing south. Now what I want to establish is that the north end of the magnet will turn faster than the south end of the magnet. So the north end of the magnet will turn faster towards the big magnet, then the south end will turn away from the big magnet. And it's pretty obvious to see that. Now, I have the aluminum pan placed in such a position that it forms an approximately 60-degree angle. So between the big magnet and the smaller magnet, the line of flux comes around in a circle like this, and it's approximately 60 degrees. So that would imitate in New York State, the dip, the magnetic dip of the Earth's magnetic field of 60 degrees. So you would see, if I turn this away and then let go, the north end will turn further than the south end. Now don't pay attention to the fact that it's going to go towards the magnet, because with the Earth it's not going to do that because it's so far away. But it's pretty obvious. It is pretty obvious. I'll try to do this as steady as I can. That the north end turns a lot more than the south, or a lot faster for that matter. So this is a key factor in my magnetic propulsion. So if you've seen my magnetic boats, you could be assured that they really work, because the north end of the magnet, being nearer the Earth's North Pole, turns faster. Now the magnetic torque, the force that makes this magnet turn, is many, many, many times more. In fact, it's 1 over the distance. It's inversely proportional to the distance directly. Now, the attraction, if I were to move the magnet where the two opposite poles of this magnet and the big magnet were facing each other, the magnet would barely move in the water at all, because it would have to move in a straight line. And then the magnetic force with regards to the distance would be 1 over the distance cubed, or at least the distance squared plus some more. So that seems to be the missing link in my magnetic propulsion experiments. And that seems to explain why they work. Thanks for watching. Stay tuned and give me a rumble and subscribe. And that's all for now.